The formula for the area of any regular polygon is 1/2 the apothem times the perimeter of the polygon. We're going to be focusing on triangles, squares, and hexagons, but this formula does apply for any regular polygon that you could have. We're focusing on these three because when we draw in the apothem and the radius, it creates a special right triangle. When we're using the triangle, and in all of these, the apothem goes from the center of the figure to the center of the side. So these orange lines that I'm drawing are the apothem. The radius connects the center with the vertex of the figure. In these figures in particular, it creates a special right triangle relationship. We know that if this triangle is a regular triangle, at each angle is 60 degrees. This radius will split that angle so that we have a 30, 60, 90 triangle, where the radius is the hypotenuse, the apothem is the short side, and half of the side of the triangle is the long leg of that triangle. In the square, we know that each angle is 90. The radius will split that to 45 degrees. So here we have a 45, 45, 90 triangle. And in the hexagon, each angle, if we use the interior angle sum formula, 6 minus 2 times 180, we get 720 for the sum. And when you divide that by 6, you'll find that each angle is 120 degrees. When you split that with the radius here, you get a 60-degree angle on the bottom, 30-degree angle up top, and then a right angle there for that apothem. So we're going to focus on these three figures because they involve special right triangles. In the square, you have your 45, 45, 90 right triangle. The apothem is the leg, the radius is the hypotenuse, and half of the side is the other leg of that triangle. In the regular triangle, you have a 30, 60, 90, where the 30 is across from the apothem. So the apothem is the short leg, the hypotenuse is the radius, and the long leg is half of the side, which is that x root 3. In the hexagon, the apothem is across from the 60, so in the hexagon, the apothem is the long leg, the radius is the hypotenuse, and half of the side is the short leg. In the hexagon, what's interesting is that since you're going to double half of that side to get the whole side is 2x, which is the same as the hypotenuse, and that only works in the hexagon. Here we have a sample problem. We're given a square with apothem of 10. So I draw in the right triangle, the special right triangle for my square here. I label the apothem, which is a part of this triangle. So I'm doing a 45, 45, 90, which was x root 2 for the rule. The apothem is across from the 45, so 10 is under the 45. This means that the other 45 will be 10, and that the 90 will be 10 root 2. So we label the rest of our triangle with what we found. And then we use that to find all the parts. The radius will be 10 root 2. The side, you have to double this 10 for the whole side, so the side is 20. Since the side is 20, the perimeter is 4 times 20 is 80. And the area formula, we can do 1/2 apothem times perimeter, which would be 1/2 apothem times perimeter. Or, being a square, we have the side. We could just square the side. So you can use either formula for the area of the square. You do end up with 400 for the area of the square. On the next square, they gave us the radius of 6 root 2. So I draw in my special right triangle. I label my radius with 6 root 2. I set up my work for finding the other sides of the triangle. 6 root 2 is across from the 90, so we put that underneath the 90 in our special right triangle here. So 6 root 2 is equal to x root 2, and when we divide by root 2 to figure out x, those root 2's cancel, and we see that x is just 6. So each of these pieces of the triangle are 6. Since half of the side is 6, the whole side will be 12. And now we can find or label our parts for what they asked for. The apothem is 6, lowercase a for apothem here, S for side, P for perimeter. If the side is 12, 4 times that is 48. And area, again, we can do 1/2 apothem times perimeter, or being a square, you can do the side squared. You get an area of 144. In our triangle, we have a 30, 60, 90 special right triangle inside of it, so I've drawn that. I've set up my table for my rule here. They gave me that the radius was 8, so I'm going to label the radius with an 8. That's across from the 90, so the 90 is 8, so under the 90 I put an 8. This means that 8 is 2x, and when we divide by 2 to find x, 4 is x. So the 30 is 4. And once we know x, we can plug that in for the 60. 4 times root 3 is 4 root 3, 4 there. And then let's label the rest of the triangle with what we just found. Across from the 30 is the 4. Across from the 60 is the 4 root 3. Since 4 root 3 is half of the side, the entire side, if you double that, will be 8 root 3. The apothem, lowercase a for apothem, is in the picture here. It's the 4. The perimeter, if we have a side of 8 root 3 and we have 3 of those, then the perimeter is 24 root 3. And then for the area, we're going to do the apothem times the perimeter, 1/2 apothem times perimeter, so we're just going to do apothem times perimeter divided by 2. Since the root 3 is the only root in this part that I'm solving, what you're going to do is just deal with the other numbers and put the root 3 on the end of it. So 4 times 24 divided by 2 will give me 48 times root 3 there, because I never had typed the root 3 into the calculator. So if you do 4 times 24 divided by 2 and then put root 3 next to it, you'll have the answer for that one. On this problem, they started by giving me the perimeter. Since it's a triangle, to find the side, we'll take the perimeter and we'll divide it by the number of sides, and we'll get 8. So in this problem, the side length is 8. But so far, I don't have anything on my special right triangle. So I need to work to get to that triangle, then find the pieces of the triangle, and then I will be able to find the rest of the items. So right now, the whole side is 8. And since right here in this special right triangle is half of the side, I know that that part would be 4. Since the whole thing is 8, that part will be 4. So across from my 60, I have a 4. And I know that the 4 is equal to the x root 3. So I need to divide by root 3 to get x alone. And this one's not going to be very pretty. I'm going to need to rationalize, multiplying by root 3 over root 3, giving me 4 root 3 over 3. We're going to leave it just like that for the 30. So x is 4 root 3 over 3. And then when we double that, you just doubled the 4. So 8 root 3 over 3 is that doubled. So let's take that onto our triangle over here. The 30, across from the 30, is the 4 root 3 over 3. And across from the 90 is the 8 root 3 over 3. So now I have my radius, 8 root 3 divided by 3. And they had already given me my perimeter, which was 24. And they didn't ask me for the apothem in these blanks, but I think they probably should have. I'm going to label that the apothem is 4 root 3 over 3. And now they asked me for the area. So the area is my apothem, which is 4 root 3 over 3, times my perimeter, which is 24, and then all of that divided by 2, or half times all of that. So to do this, you can do 4 times 24 divided by 3, then divide that by 2, and you end up getting 16 when you do all that. And then it had a root 3 in there, and it was the only root 3, so it still has root 3 in the answer. So it ends up being 16 root 3. So again, to kind of walk you through how I did that, I would do the 4. So 4 times 24, then divided by 3, and then divided by 2, and that gave me the 16, and then I had not put the root 3 on there, so it's 16 times root 3. Here we have a hexagon, which has a 30, 60, 90 inside of it as well, but it faces a different direction than the triangle. They gave me that the whole side is 10. Remember that this part of the triangle is half of that, so that will be 5. So now I have a 5 across from my 30. So I'm going to label that in my table here. And that means that the 60 will be 5 root 3 and that the 90 will be double the 5, which is 10. So I can label now across from the 90 is a 10 and across from the 60 is a 5 root 3. And let's fill in what we have so far. The radius is 10. The apothem is 5 root 3. The perimeter is found by adding up all the sides. And since all of the sides are 10 in length and I have 6 of them, the perimeter is 60. So for the area here, 1/2 apothem, 5 root 3, times perimeter of 60. So this time I wrote it like it was written on the paper with the 1/2. You can do 5 times 60 divided by 2 to get 150. And then, so the answer to that area will be 150 root 3. Again, I would do 5 times 60 divided by 2 to get the 150. Root 3 for the area there, 150 root 3. Here's the last sample. They gave us a radius of 12. That is across from the 90, so I know that the 90 is 12. So I know that 12 equals 2x. Dividing by 2, I find that 6 is x. So the 30 is 6, and the 60 would be 6 root 3. And we label that on our triangle. Across from the 30 is 6. Across from the 60 is 6 root 3. Since 6 is here, and we know that's half of the side, the whole side will be 12. The apothem is 6 root 3. The perimeter is the side times 6 because there are 6 of them, so the perimeter is 72. And the area is 1/2 the apothem times the perimeter. So I can do half of 6 and get 3, and then multiply by 72, 216 root 3. I could have also done 6 times 72 divided by 2. Either way, you end up with 216 root 3 for the area. And that is it for these notes.